Alrighty, I want to take a few minutes to kind of get you ready to do this lab because we're dealing with electric field. We just started dealing with electric force in class. It's the same principle, but I just want to make sure you know the difference. So, most importantly for the pre-lab, of course, what we're going to be using is the Coulomb electric field. Okay, so what I want to do then is look at the pre-lab. And so we're looking for the electric field at that point P. And after I record this, I'm going to put up the recording from class so you can see how to find the total field based on or the total force based on several charges, and you'll follow the same process here. So the first thing you always want to do is we're going to find the lines. Yeah, let's make that. I'll make them slightly different color. And then forces. Oops. Then there's one there. Okay, so we have the lines that are connecting the charges to point P. Now, for electric fields, when we're talking about the electric field vectors are going to go along the line connecting your point to your charge. And for negative, to go back up here and look, you see all the field lines go into negative and they go out of positive. Okay, so we're going to bring that down here. So our field lines, field vectors, are going to go into the or towards the negative and away from the positives. So let's see, charge one. So this is Q1 from the problem. This is Q2. So that means that this is electric field one, and this is electric field two. Now from here, you're going to do you're going to find the magnitude of both of these and then turn them both into vector component form. And then for the total, let's see, for the total electric field, once again, this is called superposition of the electric field. You're going to get let me write this in a place. Let me write this underneath so I have more room. Okay, so and this will give you the total electric field at point P or the superposition of the electric field. But you notice you're going to have to turn E1 and E2 into into vectors with components. So of course here, using the Coulomb electric field, you can find the magnitude of the field. Then you notice that E1 only has a positive j hat component, so that's going to be all in the y direction. E2, however, so if we redraw, and that's your point P, and then we say what you're going to notice is that you're going to have to find you're going to have to find the components of vector of the electric field 2 vector. Okay, so then once you have the vector component form of each one, so you're going to end up, so for example, you'll end up with E2. So you're going to have this in vector component form. Once you have both E1 and E2 in this vector component form, then you're going to add them together. Let's see, what does it say? Calculate the magnitude and direction of the field at point P. So once you have the total electric field, then of course you'll find the magnitude of that vector and you'll find its direction the way we've been working on with vectors in class. Okay, so this is how you differ slightly from forces, and I'll put up the lecture from class so that you can see how the forces are done in the exact same way. So let's see. The forces are, and I'll just go ahead and show you the mock-up for this. The forces are going to be pointing in the same direction, and you're going to do it this exact same way. I'll show you how that works here. So I just need to erase that and that. Because then it tells you, okay, well, fine. Now I'm going to put another charge here, and the charge is positive. So we just call that Q3. So again, when you have a charge, now it's just a charge instead of a point in space. Uh, the new charge and the positive Q1 are going to repel. So you're going to get your force vector. That's going to be your force 3-1, and it's going to point in the same direction as E1. And then positive and negative attract. So you're going to get your force 3-2, and it's going to point in the same direction as E2 because the new charge and the Q2 are going to pull towards each other. So you're going to do the same vector analysis, except this time you're going to be using electric force. So instead of just one charge over r squared, you're going to have both charges multiplied together over r squared. So exact same process twice. You're just using a slightly different form of Coulomb's law. Alrighty, that should be enough for you to be able to do the lab. And then I will post the class lecture so you can see how we worked on some of these forces in class.